Okay, good evening. Welcome to
SuperMath number 65.
SuperMath65. So what we've got here is a real interesting circumcircle problem that I saw on Twitter. And the question is, you have a square here whose sides are 20. And what is the radius of this circle? And I thought this was an interesting problem because we've been studying circumcircles. Where do circumcircles come from?
Well, they come from triangles.
Okay. How do you find them when you have a triangle?
Well, so you just take a regular triangle, just any old triangle,
Okay.
and you draw all the perpendicular bisectors.
You draw the perpendicular bisectors. Okay. And those always intersect at a single point, even though I didn't draw that very well here.
Yeah.
Okay. So what 3 points here form a triangle?
So it'll be this corner, and this point.
Alright, awesome. There's our triangle. And what can you tell me about this triangle?
Well, I know it has one side length of 20.
One side length is 20.
Are these two the same?
Interesting. What do you think about the geometry of this situation? What does it tell you about that point?
Well, it tells me that it's the midpoint.
Looks like it's going to be the midpoint. So what can I write here?
This is 10, that's 10.
10, 10. Alright, so now how do I find these sides?
Well, this is 20.
This is 20,
So you're going to do 10 squared plus 20 squared.
which is?
100 plus 400. It's the square root of 500.
Right, square root of 500.
Or 10 times the square root of 5.
We write it as 10 times the square root of 5, because that's a little bit easier number. What about this leg?
Well, that's the same thing. It's 10 root 5.
For exactly the same reason. Now what can we say about the perpendicular bisectors of these sides?
Well, we know the sides of the regular of this triangle. We could find this height.
Okay.
The height.
Alright, so here's a perpendicular bisector.
Well, since it's isosceles, the perpendicular bisector is the angle bisector.
True.
How would we find that height?
Good question.
So this is 500, and this part is 10.
Okay.
So then this height has to be 20,
Why?
because 10 squared plus 20 squared is 500.
Okay. Why else? What's another geometric reason why that height has to be 20?
Well, because it's this side.
Right, it's that side of the square. Okay. So we just learned that this height is 20 here. And it's also the perpendicular bisector. So this is 10. Right?
Yeah.
Okay, let's draw another perpendicular bisector here.
Well, this time it isn't isosceles, so. Well, the perpendicular bisector this time isn't the angle bisector.
That's true. This is not necessarily a straight line. This is the perpendicular bisectors. But what did I learn when I cut this thing in half here?
Well, these are the same.
These are the same because they're the radius of the circle. But that's what we're trying to find. What else did I learn when I drew this perpendicular bisector?
Well, well, this is 5 root 5 and 5 root 5.
Okay, awesome. 5 root 5. 5 root 5. Okay, good. Now we got to think. Now we're to the part where we really got to think.
Well, if we can find what this part is.
If we can find what that is, it looks like we'll be very close to being done. Because if we can find what that is, we can find what this is, and that's the radius.
Yeah.
Okay, so how do you think we're going to find what that is?
Well, maybe we could find what this whole thing is.
What whole thing? What are you drawing? What are you drawing that you think is a straight line? Yeah, that's not going to help. That's not going to help. How do you think we're gonna find this side here? That's the whole key. What technique do you think is gonna come into play here?
Well, I'm not sure about the Pythagorean theorem.
Right, if this is x, then this is gonna be y. We're gonna have x squared plus 25 times 5, or 125. Is that right?
It should be. It
250.
should. Yes, 250.
5.
This is 5. That's 25. Wait.
100 times 5 is 500. It's the square root. Oh, yeah. Sorry. Okay. X squared plus 125 is y squared.
So we have two unknowns.
We have two unknowns. So what can we do to find those unknowns? What can we do? Think of the geometry.
Well, if we knew the area of this triangle, the whole.
Yeah, but we don't. What do we know?
We know the sides of the whole triangle.
Yep.
And we know the height of the big triangle.
Yep.
We know this side.
Yep.
What else do we know?
What else do we know? What are some other geometric ideas in here that you know?
Well, I think I know that these two triangles are similar.
Which two?
This triangle and this triangle.
Okay. These isosceles triangles are similar. Similar triangles, very powerful idea. Do you see any other similar triangles?
Well, these two are similar.
Those two are similar, okay.
But we haven't used this triangle yet.
Right, this 20, 10, 10 root 5 triangle. Is that similar to anything?
Well, you have the other 20, 10.
Yeah? You keep looking for congruences. Look for similarities.
Is there another right triangle on the board? Well, the 2010 is similar to this x 5 root 5 y triangle.
Why?
Well, because this is the short. 5 root 5 translates to 20. The x goes to the 10.
Okay. But why are they similar?
Well, you have you only have the right angle in common. And then well, you have this angle. You have angle similarity.
This angle is in both of those right triangles, so these two right triangles have all the same angles, so they're similar. So what does that mean this side is?
Well, that x translates to the 10.
Yeah?
And the 5 root 5 translated to the 10 root 5. So, this x is 5.
Let's draw those two triangles. Okay, this one, what is the 5 root 5?
It's the long side.
5 root 5, x and y. Now draw what's the big triangle?
It's 10, 20 is the height, and it's 10 root 5.
So what does the 5 root 5 correspond to?
It's 20.
Okay, so what is x then?
The x, so 5 root 5, 5 root 5 times 4 over root 5 would be the 20.
What?
5 root 5 times 4 over root 5 is
Where's
20.
the 4 coming from?
That's the factor that you have to multiply by.
Okay.
So that means the x times 4 over root 5 is 10.
x times 4 over root 5 equals 10. So x equals what?
Well, 4x is 10 root 5. It's 10 root 5 over 4.
And how does that simplify?
It's 5 root 5 over 2.
Okay. What's the relationship between the long side and the short side?
It's double.
So how could I see this was 5 root 5 over 2 real quick?
You have to divide that by 2.
You just divide by 2. 20 to 10, divide by 2. 5 root 5, divide by 2. What's the long side now?
Well, so this is 250. And this is 125.
This
But
is, this
when
is
you
definitely not 250.
When you square them for the Pythagorean theorem, a squared plus b squared is the y squared.
Would you show me how 5 root 5 squared equals 250, please?
Well, we said that 10 root 5 squared was 500.
Okay.
This is half of that.
All right.
You have 25 times 5, which is 125.
Okay.
So this is 125.
Now, how can we tell right away that 5 root 5 squared is not 250?
Well, you have 25 from this and a 5 from this.
Okay, so?
So it's gonna end in 5.
Okay, there's no 2's. Look at the geometry, though, to tell me what this side is. How does this triangle tell me what this triangle is?
Well, it's 5 root 5 over 2 times root 5.
Which is what?
Which is 5 times, it's 25 over 2.
It's 25 over 2. Okay, and what's that?
That's 12 and a half.
No, but what is it in our picture?
It's the radius of the circumcircle.
It's the radius of the circumcircle. Pretty cool. This is a tough problem.
Yeah.
But let's review how we solved it. We were given this square, and we were trying to find the radius of the circle. We noticed that it touches the square at 3 points. That gives us an idea to draw a circle, because we know about the circumcircle. Because we know the circumcircle is the intersection of the perpendiculars, bisectors. Well, because this is an isosceles triangle, the perpendicular bisector here is easy. And then we just have to figure out the perpendicular bisector here. But we have a right triangle there and a right triangle here that are similar. Okay? And instead of, when we have similar triangles, we don't have to do lots of calculations. The big triangle, the long side to the short side is 2 to 1. So 5 root 5 divided by 2. The short side to the hypotenuse, just multiply by the square root of 5. 25 halves. So that's the radius. And we don't even have to check the other radius. We could if we wanted to, by the way.
It's the same, it would be the same number.
Hopefully it should be the same number. If this is 25 halves, remember this was 20 tall, so we just figure out what that is and then do the Pythagorean theorem to check that if we wanted to. But we don't need to do that right now. Okay?
Yep.
Alright. Good job, Hunt. I know you're tired. I know you had a long day driving back from Boston, but this is a cool problem and great at showing how geometric insight comes into play.